Well, good afternoon, everybody, and I hope you can hear me okay today. And welcome to this webinar on the question how to use Lean Six Sigma to accelerate managed stage gate innovation pipelines. My name is Jules Attard. I'm a Master Black Belt at 100% Effective, and I'd like to thank you for spending half an hour with me this afternoon here. First, the technical stuff. Please type any questions you have during the webinar in the chat box at the lower left of the screen. If it's something that is interfering with the webinar, we'll try and resolve it immediately. I would encourage you to ask any questions during the webinar as we go along. I will take all those questions at the end if that's okay. So, on to the subject of the presentation, the need for speed. Many companies use stage gate processes to manage their innovation pipelines. Although these vary between industries and companies, at the core of all of them is a sequence of decision points through which every innovation has got to pass. The resources to conduct the next stage of development aren't released until you've passed answered the critical questions of the previous phase, and therefore we have a decision point to make to decide whether to go ahead and release those resources. Many companies use them, but I'm afraid that few are truly satisfied with the results. Many innovators find this process restricting. They find that the time spent preparing for review takes them away from research. They find that management find that they're disappointed with the quality of the decisions, and they find the time required to make those decisions quite a burden upon their day. There's often a sense that the stage gate process itself is actually slowing up innovation, delaying the launch of new products, whereas it was intended all along to accelerate the new product development. So, although they're an essential part of managing innovation, they have a lot of problems. In this webinar today, I intend to show you how the application of some simple Lean Six Sigma techniques can reduce delays to projects at stage gate reviews, and also how to improve the decision-making in quality. That should result in faster time to market, lower costs of innovation, and freeing up more time to be innovative. And as I said, I will conclude with a short question and answer at the end. Do please type in any questions in the box as we go along, and I'll try to answer all of them in the time available, and if not, then I will come back to you with an answer afterwards. The management of innovation through some kind of decision point is a business process. So like any business process, it's something that we can map. And this slide shows a very typical process for a single decision gate. It starts with generating the results of an experiment. We report that experiment. We prepare a plan of activities for the next phase. We then go to management to take a decision whether or not to pass the project to that next phase. And then the resources are released and the next phase of activity starts. It's very simple, and all processes have something like this at their backbone. And that shows the process how it's meant to happen. The reality, which I hope you can see on this next slide, describes the process as it might be experienced in real life. Processes rarely happen in the way that the procedures say they do. And one of the first things that we would learn when we're learning how to do continuous improvement will be to map the real process rather than the one that's written down in the procedure. So this map actually shows the real processes that happened in a project that I was involved in. It looks a lot more complicated. So it starts off, we've completed the experiment, but before we can review the results of this experiment and plan for the next phase, we're going to have separate reviews, perhaps functional reviews and subject matter subcommittees, which review the experimental results and the plan for the next phase. Each of those subcommittees proposes changes to their report or plan. So the reports and the plans have got to be rewritten and resubmitted and reapproved. Unfortunately, by this point, some of the project team members can't come to the team meeting because they're working on 3 or 4 other projects as well. So the planning and the replanning has further delays and further cycles of waiting. Finally, the results of the plan are ready for the decision point. We've now got to wait for the management meeting that's next been scheduled, which might be 1 or 2 months away. And then we've got to have another wait because actually the agenda is so full at that management meeting that we can't get onto the agenda, and we've got to wait until the meeting following. Sometimes the management get everything together and they don't have enough information to make the decision. Perhaps, despite all this preliminary checking, there's some results have not been presented in a critical way, or there's a crucial chart missing, or the plan that was presented failed to consider an alternative scenario. So the project goes back into further preparation and it comes back for decision again. Eventually, the project is approved for progress to the next phase. And at this point, there's a further delay because the resources that were available when the project was ready have now all gone off to work on other projects. So now the project leaders have to go and find replacements. And finally, the process begins again with further experimentation. It's a lot more complicated than that original process was meant to be. I do hope that your decision making doesn't look quite like this one, but probably you'll recognize some of the failings from your own experience. In Lean Six Sigma, we're going to identify the consequences of all those complications. We're going to find the root causes, and we're going to propose solutions to them. And a very powerful way to do that is to look at each activity in that map, considering the waste that happens in the activity and between each activity, and the value that's added. Waste is any action which doesn't create value for the customers in the process. So in the innovation process, we might identify several customers. They could be the business which seeks to launch the new products, the management who wish to exploit learnings from the research in other areas, and the project team themselves who are seeking the release of further funding. All of these people are customers of the decision-making process. And when we consider value, I've got to look at the value from the perspective of all those people. When we do that, we find that all kinds of value can always be recognized by 3 factors. First of all, the customer wants the results of the activity. They're prepared to pay for it, or they put value upon it being done. The activity itself adds some information, adds knowledge or content, so that the outputs differ from the inputs. And thirdly, that the activity is done correctly. Any kind of activity which doesn't satisfy those 3 criteria is not value adding. And conventionally, we separate this into 2 types. But the objective is the same, to reduce or eliminate anything that doesn't add value. Non-value adding work could be something called essential non-value adding. These are things we have to do to stay in business, but the customer themselves doesn't value. Perhaps it's because a regulator or a government agency says you have to do it. For example, completing a tax return or a money laundering check. Or if you don't pay staff or collect overdue payments, you go out of business quickly. So these are essential non-value adding work. The other kind of work which doesn't have value is waste, which nobody wants. It's possible to argue in innovation that value is only added when new knowledge is being gained. So from that perspective, everything I showed on that process map between the end of one experimental phase and the start of another one is not value adding. The crucial distinction though is that some of it is essential to the functioning of the business and some of it is pure waste. And I'm going to focus very much upon the pure waste elements of the delays. And one of the ways we can recognize waste in the process is using something called the 8 wastes, which is listed on this next slide. And the 8 wastes, it's a convenient way a shorthand to identify waste in a business process. One way to remember them is to use an acronym called downtime. So I'll go through each of these briefly. Each time we create a defect, an error, or something that needs to be corrected, we produce a waste because the time and the resources spent making that defect are wasted. More time has got to be spent putting it right. That's called rework. Overproduction is when we make more than the customer needs at the immediate time. This overproduction becomes inventory, and the time spent making it can't be used to make something else that we perhaps needed sooner. Waiting is when the process step can't happen until something that was needed or some approval is received. Additional operations are sometimes called over-processing, is doing extra work, gold plating, doing things that aren't important to the customer, such as answering questions that didn't need to be answered. Transport waste occurs when product or information is moved unnecessarily between people, and motion waste is the time that the people themselves spend moving between offices or equipment or different locations in your company while doing the job. Inventory is all the stuff that builds up in the process that is partly complete or at the end waiting to be used. It represents value. Value went into making it, but it could become obsolete before the customer uses it. Information can be inventory because if we don't exploit that information quickly, it rapidly becomes out of date. Our competitors have come up with the same invention quicker than us. The final waste in this list is employee talent. For example, escalating a decision to a higher level than was actually necessary. These wastes, and I've listed them in a very generic way here, they can be found in any process, not just the innovation process. So what I'd like to do is to look at specific examples of some of these wastes that are commonly found in the stage gate decision-making process, and also make some suggestions how to eliminate them. Over-processing is very common. It's very common in projects that project teams will deliver more information that is needed at that stage of a project, just in case. Often they take the form of answering questions which don't need to be answered until a much later stage of development. At one oil company that I worked in, they had a very rigorous phased approach to developing new oil fields, but they found that none of the project teams followed it. Each team tried to answer every question, technical, economic, political, and so on, about the project in the initial phases. They got no work from doing this because the issues investigated early had to be re-evaluated once the project reached a later stage. Over-processing, or gold plating, as it's sometimes called, is clearly a waste of resources, since some projects will be killed. I think there may be some line issues, and I'm just going to turn off my webcam. I'm hoping that improves any sound quality issues you may have been having. So as I was saying, over-processing wastes resources, and it wastes resources because some of those projects will be killed, so the information is never actually needed, and all that work was wasted. And it creates delay as teams do work that wasn't necessary. Another type of over-processing, which was one that we saw earlier on the process map, is when people subject their project to multiple reviews by multiple layers of management, each of which is asking the same question. If they're asking the same question, they're not really adding value, and I would challenge the need for those meetings. The reverse side of the coin to over-processing is rework, is when the project doesn't answer the critical questions it was meant to. That prevents management reaching any kind of clear no-go decision, and the teams have got to go away to prepare again. Since the project teams and management would all have to spend more time on this particular decision than was originally planned, the result is that your busy people just got a whole lot busier. The solution to both over-processing and rework is to develop a clear contract of expectations for each gate review and to standardize it for every project. Make sure you stick to this contract. The problem is that management behavior itself can encourage over-delivery and over-processing. Each time management asks a question of a project team earlier than the process required it to be, or a question that didn't need to be answered at all. They create the conditions for the team to over-deliver next time round. The benefits of removing over-processing and rework actually build upon each other, because once you stop work on the things that don't matter, you increase your attention on the things that do. Another very common form of waste in project delivery is waiting until the steering or management committee can approve a project and release funds for the next stage of development. Teams can't advance until their project's been reviewed by management, but the management only meet to review the new products on the second Tuesday of the month, so the product has got to wait until the next month. If you really want to eliminate this kind of waste, you need to schedule stage gate decisions when each project needs them, rather than at the convenience of the management diary or the phases of the moon. In lean terms, this is an example of using pull to schedule decisions when the customer, in this case the project team, needs them. Excessive waiting will result when a project has to pass through a succession of subcommittee reviews before it reaches the main body. So, as we mentioned this one earlier, each additional step creates a delay. So if you can streamline a process by eliminating unnecessary pre-meetings, you will make the process faster. It's not uncommon that scheduled project reviews have to be postponed due to the availability of one or two people. Where it's possible to find a deputy for your busiest people, you can sidestep this problem. We experience this problem and the solution every time we queue at a supermarket checkout or an airline check-in desk. The queue moves quicker when we can move from one busy operator to another till. And this actually works in project management as well. It may not be possible that you can delegate authority to a deputy, in which case, manage the time of the people who can't make all of your meetings by using pre-reading to gather their input in advance, rather than postponing the meeting until they can actually attend. In one pharmaceutical company that I worked with, the queue of projects to be reviewed in each month was so great that they never completed the list of projects due for review, and they had to be held over to a following meeting. Clearly, reducing the time spent reviewing each project through standardizing the presentation and eliminating over-processing, which is some of the things I talked about before, were very effective. But another effective solution is to just reduce the number of projects needing to be reviewed by managing fewer projects. Working on fewer projects at the same time reduces the burden on this gate review meeting, but it isn't the only benefit, and it's an application of something called Little's Law, which I'd like to explain now. In 1961, this is the only equation I'm going to show today, by the way, but in 1961, a professor at MIT called John Little published a proof of the relationship between average lead time, work in process, and average completion rate. Over a period of time, the average lead time of a process equals the number of things being worked on at any one time, divided by the average rate at which those things are completed. When the process is project management, the average lead time to complete a project equals the number of projects in progress divided by the average completion rate for those projects. The equation is very simple, and in fact it may not look very impressive because it's so simple, but it's actually very, very powerful. It was originally developed to understand the behavior of customers queuing at a bank or in a shop, but it's been shown to apply to processes in any kind of business. From very simple to very complicated ones, regardless of how the work arrives or how the work leaves the system, and regardless of how the work is prioritized. Because of this power, it's one of the fundamental building blocks we can use to investigate and improve business processes. And I'd like to illustrate this law by looking at a very, very simple process: people moving along a travelator at an airport. So if you imagine you're at an airport and you're just watching other passengers moving along the moving walkway, that travelator represents our process, and each passenger is a piece of work in the process. We can observe when work starts as they step on and when work ends as they step off. And the lead time is the time taken to pass between one end of the travelator and the other end. So there are several passengers on our walkway. The number of passengers on the walkway at any given moment is a measure of work in process. But the lead time is the same for all of them. It's the speed of the walkway. The number of passengers getting on each minute equals the number getting off. At least I hope it does, unless they're vanishing into thin air. So we have a measure of the completion rate of the process, how many passengers leave the walkway each minute. So what would happen if the number of passengers getting on and off each minute increased? Our completion rate would increase, but it would still take them the same length of time from the beginning to the end of the travelator, because we haven't changed the speed of that. So all that happens is that the number of passengers, which I'm calling work in process, increases. If we want to reduce the lead time, we would have to speed up the travelator in some way. So the same number of people get on and off as before, and the number of people who are on the travelator at any one moment would be fewer. So all this law has shown us is that the ratio of work in process to the completion rate, which equals the lead time, is a constant. And I know R&D projects or projects of any kind are a lot more complicated than people on an airport walkway. For a start, the project duration isn't the same for every project, but we can still apply the principles to any kind of work. We don't, when managing projects, have a magic lever we can pull to change the project speed. But using this equation, we can show that there are two ways to reduce lead time for any process. First of all, we can reduce the amount of work in process. And secondly, we can increase the average completion rate. Increasing the completion rate for a project means hiring more people, which costs money and takes time. Or we can make it work faster by taking some waste out of the process. This might not cost more, but it will certainly take time to achieve. By contrast, reducing the number of things being worked on is something that you can do relatively quickly, and it reduces the lead time for a project just as quickly. Reducing WIP to reduce lead time is something that has been successfully used in project management around the world. For example, in new product development and marketing, instead of spreading the project resources thinly over many projects, they're assigned to a smaller number of the highest priority projects. And we only start additional projects when the first ones are completed. Reducing the number of projects and assigning each resource to work on fewer projects means that those projects will be launched sooner. But if you notice, looking at the diagram on the right compared to the one on the left, exactly the same number of new projects in total are launched over at the same time. The department still produces the same number of launches because they haven't changed the staffing, so the completion rate hasn't changed. But by reducing the number of projects being worked on at any one time, the lead time of each one has reduced. Notice that none of the projects are delivered any later than they would have been under the old system. The only impact on the lower priority projects is that we delayed their start. That's actually a good thing, because there's less chance that the customer requirements on those projects will change between the beginning and end of the project if we start it later. And maybe our business will actually find a higher priority project. So rather than starting a low priority project and then stopping it, you haven't committed any resources to a low priority project. And if something else comes along in the future, you can work on that instead. Reducing lead time in project management means that each project will complete faster, new projects will launch sooner, and that allows your company to secure greater competitive advantage. And if their product's patented, they'll sell it for longer before the patent expires. So reducing lead time in new product development is a way of generating more revenue over time. The first projects start earning that revenue sooner, and the last projects to complete still generate the same revenue as they would always have done. Now, if you come back to the concept that we talked about earlier of the stage gate decision process, you can actually exploit the stage gate decision process as as a way to control WIP in your process, as a way to control the number of projects in the process. Companies that have adopted a ruthless control of the number of projects in progress have gained terrific benefits of lead time and profit advantage over their competitors. It does take time to see the benefits because we have to first close or finish the existing projects. And it also requires leadership discipline to be maintained because there's a great temptation to start additional projects before the resources become free from other projects. You need to have confidence that the queue of projects will really be delivered faster and more reliably. And as you start to see that, that will help. But many companies have failed to make this approach work because they couldn't stop themselves starting additional projects, even though they knew that adding more work in process would extend lead time. So management have got to understand and commit to this principle of controlling WIP in order for these benefits to be achieved. Using that knowledge, the stage gate can actually be a way to reduce lead time instead of a bottleneck, because you can limit the number of projects in each phase using the stage gate to control the start of work, particularly the start of the initial phase of project development. Remember, you don't reduce the number of projects per year by delaying the start of some of them. You just reduce the lead time. Reducing the number of projects in progress has two other benefits. Firstly, it reduces the burden on those management meetings, which are frequently the rate-determining step in an innovation project. But secondly, it helps to eliminate multitasking by project team members. It's not often realized how damaging high multitasking can be to people's time, and therefore to lead time. In one published time analysis, which is shown here, project engineers were found to spend a little over 16% of their time doing core design work due to high multitasking. That's the image on the right. As they were assigned to more and more projects, they spent longer managing their time and reporting to different project leaders than they did actually working on each project. Don't let the multitasking of project team members delay completion of project work, including the tasks of preparation for stage gate decisions. Instead, assign these critical resources to a smaller number of projects. So therefore, working on fewer projects at any one time is an easy way to reduce the impact of multitasking in an organization. In this webinar, I've described three essential approaches to accelerating projects through the dead time of stage gate reviews. First of all, streamline the process. Schedule your reviews when the project needs one rather than when the diary allows it. And eliminate secondary reviews which introduce delay but don't add any knowledge. Secondly, prevent the availability of key people becoming a problem for everybody else by finding deputies for them, by finding ways to gather their input outside of meetings, and by reducing the number of projects they're assigned to. And finally, work on fewer things, but get those few things right. Managing the number of live projects down. Have a clear contract of gate review expectations, which prevents both over and under delivery by project teams. I hope you found this webinar informative and helpful. And if you'd like to explore any of the concepts we've talked about some more, you might be interested in our Lean Six Sigma Green Belt course, which we've designed specifically for people working in R&D. Please get in touch with us if you would like further details of the course. You can also get in touch with us by visiting our blog, by signing up on our website, by joining our LinkedIn discussion group, and indeed following us on Twitter. So we'd love to hear from you if you would like. So at this point, I'd like to thank you for your time this afternoon, or indeed this morning, depending on where in the world you are. And I'd like to take any questions. The webinar was due to complete in 30 minutes, but we're not going to be discontinued, and I can take as many questions as you have time to submit. I just pause there for a glass of water and to give anyone a chance to type in a question. Okay, well, I've got a question here from somebody which says, actually, I understand about reducing the number of projects in process, but how would I go about reducing them in reality? So thank you for that question. There are two ways I can think of immediately. The first is to rationalize your existing portfolio and actually kill some projects. There are probably some live projects which have been going nowhere for a while, and or where the original justification is no longer valid because perhaps the market situation has changed. You can usually find such projects if you haven't done a review for a while. Find and stop them. The second way is the harder one because it requires the management commitment to a new way of working, and that's delay the start of new projects until the number of projects that are live has actually dropped to your target level. So until you reach that point, you build up a queue of projects. You just don't start new ones as resource becomes available. Instead, the resources that you free up from completion of a project, you assign to help other live projects so that they finish faster themselves. I've got another question here, which I think is a bit related to that one, which is that I got two questions. One is, do you want me to ask a question? Yes, please. If you have a question, type it into the box at the lower left and press. You can send it to presenters or you can send it to everyone as you wish, and I'll respond to any that have come through the chat box. Just while you're doing that, I've got a question here. It says, okay, every one of our projects is different. So how do I decide what is the right number of projects for my organization? It's a good question. What I've seen done is, you have to. There isn't a simple answer that I can communicate over a webinar like this, but in general terms, what you try to do is you've got to reflect that a bigger, more complex project is going to need more resource than a small, simple one. So a way that this is done is to count project equivalents. So, for example, one complex project might count the same in your system as 3 simple ones. So when you've got room in the pipeline for a new project, you can start one complex one or 3 simple ones at the same time. And a way to approach that might be to use the resource estimates for each project to determine how complex they are. I've got a question here from Heidi. Thank you very much, Heidi. I'm just reading it. Yeah, it's okay. So good point. At the beginning of our project, there's a long lead time awaiting samples of raw materials to arrive. So if we reduce the number, if we delayed the start of those projects, we would spend more time waiting. And obviously have to sort of look at the amount of waiting time there was there, and if that's the significant delay rather than the later stages in the process, you might well be inclined to order raw materials early. But what you're trying, but with the risk of those raw materials not being needed if you then decide to work on a different project. So what I think you could do is to raw all of the raw materials so that that doesn't delay the start of the project before you assign any internal resources to the project as a way of minimizing the impact. I've seen something similar done to this in some R&D that I worked on, where people would take some decisions at risk. So they would actually decide to commit to purchasing some raw materials before they had approval for the next phase of activity, because they didn't want that to be delayed. And I think that that's an equivalent situation to the one you're describing there. I hope I've understood the question well. Okay. Another question here. From Stefan, thank you very much. Some members on the team have little input in a given project, so they tend to be assigned to multiple projects to ensure that the work is allocated to them. So how does that link into the idea of having less projects working at the same time? Clearly, I think that there's an answer in two parts to that question. First of all, the right number of projects for your department is really decided based upon the critical resources rather than perhaps the minor members. So when looking at how many projects you should have, I would look at it in terms of the resource demands upon the critical people rather than the ones who are able to. I sometimes find that somebody's able to work on 10 or a dozen projects simultaneously. They're still going to be having this multitasking problem though. So for those, you do need to find a way of recognizing that anybody who's working on many projects simultaneously is probably becoming an obstacle to the speed of that project, even though they're only working a small amount of time on each project, simply because of the amount of time they'll spend changing from one project to the next. So multitasking remains a problem, even when people have only a small input to make on each project, simply because the project can be waiting for their input. It may only be a small part of their time, but it can be critical to the progress of the project. I hope I answered that question. I hope I answered the question that you intended to ask there, and I haven't misunderstood it. If I have, do please. If I have not answered any of those questions properly, do please contact me either on Twitter. You can see my hashtag there, or through the 100% Effective website. I'd be very happy. I think we've actually. Let me just check and scroll back. Thank you, Heidi. Yes, you can certainly have a copy of this presentation. First of all, it will be available through YouTube. We've recorded it going along, and the whole presentation, including my voice, will be available on YouTube afterwards. I'd be also very happy to discuss with anybody any questions that are raised by that. What I will make sure we do is that everybody who was registered and I can see your names here, we'll send you a link to the YouTube recording when it's been posted. And thank you very much for the feedback and for your time this afternoon. So if there are no more questions, I will wish you the best for the rest of your day and for the weekend.